Imagine waking to satellite images showing hundreds of volcanic plumes rising across the planet. From Indonesia to Iceland, the Andes to Antarctica, eruptions begin almost at once. Some mountains explode with ash and gas, while others pour glowing lava down their slopes. The first surprise is that no single type of eruption would dominate. And the greatest global danger would not necessarily be lava. It would be what thousands of eruptions could do to the atmosphere, food supply, and modern infrastructure. In reality, such an event is essentially impossible. Volcanoes have separate magma systems, and there is no known mechanism that could make every volcanic region erupt simultaneously. But as a scientific thought experiment, suppose Earth's active and potentially active volcanoes suddenly erupt together. The consequences would spread from local disasters into a global crisis. Within minutes, communities close to explosive volcanoes would face the greatest immediate danger. Pyroclastic flows could race down valleys as scorching clouds of ash, gas, and rock. Around other volcanoes, lava fountains and glowing rivers would destroy roads, houses, forests, and power lines. These eruptions could be devastating locally without producing enormous ash clouds. At snow-covered peaks, heat could rapidly melt ice and snow. Water mixed with ash and debris could form lahars, fast-moving volcanic mudflows that bury river valleys. The Pacific Ring of Fire would become one of the most dangerous regions on Earth. Indonesia, Japan, the Philippines, Alaska, and the Andes contain many volcanic systems. But volcanic activity is not limited to the Pacific. Iceland, East Africa, the Mediterranean, the Caribbean, and remote ocean islands would also face severe disruption. Many eruptions would happen beneath the ocean, where water could contain much of their material. Only certain underwater explosions or volcanic collapses would create dangerous tsunamis. Within hours, the sky near major explosive eruptions could turn dark. Thick volcanic ash would reduce visibility, cover streets, contaminate water supplies, and damage machinery. Ash looks soft, but it consists of tiny fragments of rock and volcanic glass. It can irritate lungs and eyes, clog engines, and become dangerously heavy when wet. Roofs near major ashfall zones could collapse under the weight. Roads would become slippery, electrical systems could fail, and water treatment plants would struggle. Air travel would be among the first global systems to break down. Jet engines can be severely damaged by volcanic ash, forcing enormous areas of airspace to close. Passenger travel would slow dramatically, but cargo would matter even more. Medical supplies, replacement parts, electronics, and other time-sensitive goods could be delayed worldwide. Ports near volcanic coastlines could be buried in ash or cut off by damaged roads. Global supply chains would quickly become unpredictable even far from any crater. Then the crisis would move beyond the eruption zones. Powerful explosive volcanoes can inject sulfur dioxide high into the stratosphere, far above most ordinary weather. There, sulfur dioxide can form tiny sulfate aerosols that reflect part of the sun's energy back into space. A pale volcanic haze could begin spreading around Earth. This is where the scenario becomes much larger than thousands of local disasters. The atmosphere could connect eruptions that were geologically unrelated beneath the ground. Not every volcano would contribute equally. Gentle lava eruptions might release gas without reaching the stratosphere, while explosive eruptions could dominate the climate effect. The exact cooling would be impossible to predict without knowing the size of every eruption. But many major eruptions could produce an extraordinary temporary reduction in sunlight. Days would not suddenly become night everywhere. Instead, many regions could experience hazier skies, unusual sunsets, cooler temperatures, and less sunlight reaching crops. Ash itself would mostly fall from the atmosphere relatively quickly. The longer-lived problem would be sulfur-rich aerosols high above the clouds. Within weeks and months, agriculture would become the central global concern. Crops need predictable temperatures, rainfall, and sunlight, and all three could be disrupted. Fields close to volcanoes could be buried under ash. Farther away, Cooler growing seasons and altered rainfall could reduce harvests without any visible lava nearby. Modern farming also depends on transport, fuel, fertilizer, electricity, and international trade. Damage to these systems could make food shortages worse than crop losses alone. Countries with grain reserves and productive farmland might cope better at first. Regions dependent on food imports would become more vulnerable to shipping delays and price shocks. The disaster could therefore look surprisingly ordinary in many distant places. No lava would be visible, yet supermarkets, airports, factories, and fuel networks might stop functioning normally. Human health effects would vary enormously by location. Near eruptions, ash and toxic gases would dominate, while distant populations could suffer more from shortages and disrupted medical services. Sulfur dioxide near the ground can irritate the respiratory system and contribute to volcanic smog. Acidic volcanic compounds could also damage vegetation, water supplies, and infrastructure. Would humanity go extinct? Probably not, simply because every volcano erupted, because eruption size matters enormously and many volcanoes are far less explosive than famous supervolcanoes. But civilization could face one of the most severe global emergencies imaginable. Volcanic regions would suffer direct destruction, while almost everyone could feel economic and climatic effects. The outcome would depend heavily on how many eruptions reach the stratosphere. Mostly small eruptions would be disastrous, but very different from simultaneous giant explosive eruptions. If several huge caldera systems also produced extreme eruptions, the scenario would become far worse. That possibility goes beyond what all volcanoes erupting alone actually tells us. After the eruptions weakened, ash clouds would gradually settle and transport routes could reopen. Yet damaged cities, farmland, ports, and displaced communities would take years to recover. The atmospheric effects would also fade rather than remain permanent. Sulfate aerosols eventually leave the stratosphere, allowing more sunlight to reach Earth's surface again. Volcanoes also release carbon dioxide, but the immediate climate effect of large sulfur-rich explosive eruptions is usually cooling. Long-term warming from this event would be much less certain. Over longer periods, ecosystems would begin reclaiming lava fields and ash-covered landscapes. Volcanic material can eventually create fertile soils, long after the original destruction. So if every volcano erupted at once, the world would not simply disappear beneath lava. The global threat would be a chain reaction through atmosphere, agriculture, transport, energy, and food. It is a reminder that civilization depends on systems spread across the planet. Hundreds of distant disasters could become one connected crisis without the volcanoes themselves being connected. If you enjoy exploring extreme questions about our planet and the science behind them, leave a like and subscribe to WunderAtlas World for more journeys into the unexpected. Until the next wonder.